Well, good afternoon. I'm Vince Smith, Director of the AEI Agricultural Policy Studies Program, and it's my genuine pleasure to welcome you all to this panel event on conservation and agricultural research and development, pathways to efficient and effective climate policy. The issues our distinguished panel will be discussing today are of central importance in the current debate about the 2023 Farm Bill and for the future of American agriculture and global agriculture, and concern the most effective use of scarce federal resources to address the climate change impacts of greenhouse gas emissions from the US agricultural and more broadly, the global agricultural sector in addressing climate change. Through the Inflation Reduction Act, federal funding, for example, has been made available for a suite of initiatives that will pay farmers to adopt or continue practices that, at least on the surface, appear to mitigate carbon emissions. One of our speakers will be talking about those and other related programs. There's also strong support among some congressional delegations for substantially increasing federal investments in agricultural research and development programs to increase on-farm productivity and perhaps especially crop yields. The questions being addressed by today's panelists, therefore, include what approaches will be most beneficial for the US and global economies with respect to food prices, climate change, while taking account of fiscal responsibility. Public investments in agricultural R&D or public investments in conservation programs or an all of the above approach, which, if you have heard speeches from President Biden, have been a theme in his speeches. He may or may not be right. After all, presidents are not always right. Our panelists are extraordinarily well qualified to discuss these issues. Our first speaker is Dr. Philip Pardee, Professor of Science and Technology Policy in the Department of Applied Economics and the Director of the GEMS Information Center at the University of Minnesota. With broad support from both private and public organization, his GEMS Center brings together the College of Food and Agricultural and Natural Resource Sciences and the Minnesota Supercomputing Institute to develop and deploy computational systems that address complex problems to unlock innovation in the agri-food sector. Dr. Pardee is a fellow of the American Association of Applied Economists, whose work on US and global investments in agricultural science has been path-breaking. His insights on the impacts of those investments on agricultural productivity have changed our understanding of the relevance and importance of US federal agricultural R&D investments. Our second speaker is Dr. Eric Lichtenberg. He is a professor in the Department of Agricultural and Resource Economics at the University of Maryland. He is also a fellow of the Agricultural and Applied Economics Association and a former co-editor of the American Journal of Agricultural Economics. He has served on National Academy of Science expert panels on GMP crops, basically genetically modified crops, and he's also served on panels addressing precision agriculture, about which there are a couple of pieces of legislation being proposed in Congress right now. Much of Dr. Lichtenberg's seminal work has focused on the design and effects of policies that incentivize farmers to address environmental impacts of their production practices. As he puts it on his website, if it's nasty stuff in agriculture, he's looking at it. Dr. Sahara Moon Kapitan is the let me try this again. I'm sorry, Sahara. Sahara Moon Kapitan is the executive director of the Foundation for Food and Agricultural Research. She's a plant scientist who is passionate about sharing the importance of plants and agriculture and holds a bachelor's degree in biology from Stanford and her PhD in plant physiology from Harvard University. She has more than 15 years of experience in federal leadership positions. Prior to her current role, she served as the executive director of the United States Botanic Garden, and before that held multiple positions at USDA and then USAID, including serving as Deputy Assistant Administrator in USAID's Bureau for Food Security. With a very different background, but equally important, our fourth panelist is Kenneth Parker. Kenneth is a sixth-generation Floridian, a farmer and rancher who's raised his crops, strawberries. Well, right now he's leasing out his strawberry land because he's a full-time executive of the Florida Strawberry Growers Association. But he still has his hand in agriculture, running the livestock operation that his family has been engaged in for 6 generations, I guess. Is that right, Kenneth?
Off and on, yes, sir.
Off and on. Kenneth brings a critically important perspective to this discussion in his role as a hands-on farmer and farm organization executive, dealing daily with the complexities of regulatory and policy issues that involve conservation and innovation. Our first 2 speakers will have 15 minutes for their initial presentation, followed by comments from our other 2 participants, and then a discussion that provides further insights from among the panelists. We will conclude with about half an hour of Q&A with questions coming from the members of the audience right here at AEI and also from live stream folks. If you're live streaming and you want to submit a question, you can do it in one of 2 ways. Either by email to Benjamin, that's Benjamin .Goren, Goren, at aei.org, or via Twitter to hashtag AEI Farm Bill. You can send those questions to us at any time during this event, and we will be anxiously awaiting them. At this point, it's time to turn to our panel and to invite our first speaker, Dr. Pardee, to share his insights about where U.S. agricultural research funding is today and where agricultural policy as it concerns federal research funding for research needs perhaps to go. Dr. Pardee, the floor is yours.
Thanks very much, Vince, and it's a pleasure to be here. My title of my talk is Revitalising the Slow Magic of US Agri-Food Research, and it was a deliberately chosen title to try and reflect the fact that despite the sort of sense of a fast-paced, rapidly technological changing realities in agriculture, as in other sectors, which is true, how those innovations and those technical changes come about is actually a lot slower process than most people think about. And so we need, it still takes 7 to 10 years to develop a new wheat variety, for example, and it takes some time to bulk up the seed and to spread that variety out and to be adopted by farmers. And so from when you spend some R&D dollars to the time it actually impacts in farmers' fields and exacerbates its impact, we need to be very forward-looking because these processes take years, if not decades, to roll out. And so in a city where the electoral cycle is a 2 to 4 to 6 year cycle, we need to be thinking in these decadal terms rather than these short sort of political cycles. And so I'll try and present the evidence in a way that tries to shift our trajectories of what has been a pretty dismal trajectory over the past several decades with respect to federal funding in the US food and ag R&D sector. And this slide in a nutshell shows the realities for the last 70 years or so in terms of, in inflation-adjusted terms, in terms of the relative trends in publicly performed food and ag R&D and privately performed food ag R&D. And so the latest numbers we've been able to put together are up to 2019. And the sad fact is that public agricultural R&D peaked in 2002 in terms of inflation-adjusted real spending. So we've actively been disinvesting, spending less year on year for the last 2 decades in federal and state-performed public food and ag R&D, such that the investment that we realise today and putting in today is back to where we were half a century ago in real terms. So that's the resources we have to work with. Meanwhile, the private sector has continued to grow. It passed, in terms of total spending, the public sector in the mid-1980s. And as you can see, even in the last few years of these data, the growth in private agri-food R&D has actually flattened out as well. So nonetheless, we're at a situation where we have about 70% of the research in the US ag and food sector is private and 30% public. I think that's a big change from a lot of policy folks tend to still think that it's a predominantly public sector entity, but in fact there's now a big private sector presence in this space. And so that also, we won't have time to talk about it today, but that involves fundamental issues about access to information and innovations and so forth. So there's pluses and minuses, certainly a lot of pluses from private sector participation, but it also implies a rethink about the roles of the public sector in that new reality. If we pass out the data a little bit and go down below the high-level figures and look at here on the green line what's been going on with respect to intramural USDA research, we can see a peaking of decades ago and then a decline. And if we're looking at SAS, that's State Agricultural Experimentation funding and spending, that's the land-grant universities, the state government funds going into those systems have been declining, as have the federal funds, such that if we compare today, where we stand today for the USDA, they're back to where they were in 2013. And in fact, if you look to the left on the green slide, they're effectively back to where they were in the 1970s, as is the state agricultural experimentation systems as a whole. They're back to their spending levels in 1976. If you look, the public dollars that goes into those systems comes from two primary sources, that is federal funding and state funding. So state funding has dropped to the level it was 2 decades ago, federal funding has dropped to the level it was 2 decades ago. State funding is back to where it was in the 1950s. And so there's been a big withdrawal of state support into those state agricultural research systems. If we try and put the US in a global context, we can see the consequences of what's been going on in the US vis-a-vis large agricultural economies in the rest of the world. So the vertical red line shows that in terms of public spending, China started out spending in purchasing power parity terms the US back in 2012. And if you take Brazil, India and China together, 3 large agricultural economies, they started outpacing the US investment nearly 2 decades ago, such that the Chinese public sector system now invests 34% more for every dollar the US puts in. The Chinese put $1.34 in. And if you combine Brazil, India and China, they're now putting nearly $3 into the public agricultural research systems relative to every dollar that goes into the US system. So that's a huge change in the geographical location of investments in public food and ag R&D over the last several decades. If we look at public and private food ag R&D spending and compare 1980 to 2018, we can see that China is now the dominant player, accounting for around, by my estimates, about 23% of all public and private food and ag R&D in the world. If you look on the 1980 column, China was nowhere near the top 5 or 10 or 20 or so back in 1980. So in the last 4 decades, they've moved way up and now sit at the top of the pack. The US has lost market share. It's dropped from 18% to 14% in public and private spending. I should draw your attention to the bottom couple of figures here too. Just the top 3 countries alone, that is China, the US and Japan, account for 45% of the entire world's spend on food and ag R&D. The top 10 countries alone account for over 2/3 of the spending. And if you worry about international development, where I spend a fair bit of my time concerned about ranked countries in terms of their R&D spend, the bottom 50 countries account for just 0.4% of the entire world's food ag R&D spending, and their market share has been declining over the last 4 decades. And half of those countries in that bottom 50 are based in sub-Saharan Africa, a part of the world where we have very large and rapidly growing populations and where we have a major dearth of technologies going into those agricultural sectors. Vincent mentioned that productivity owes a lot to investments in R&D, and the way economists think about the relationship between R&D and productivity is to think about stocks of knowledge, so that if we're looking at output in agriculture or productivity in agriculture, say in 2019 or now, that doesn't just come from investments in 2019, that comes from an accumulation of investments over the previous several decades. And so the way I think about it is that those R&D, historical pattern of R&D spending ends up accumulating into stocks of knowledge, which end up being in the forms of tacit knowledge in the brains of crop breeders and other scientists working in agriculture, sits in library books and largely sits and captured in scientific papers or in patents and things of that nature. So that's sort of a physical representation of the knowledge base that's accumulated over the past several decades that actually drives productivity. But economists find it hard to add up tacit knowledge and patents and papers, and so we've devised methods to try and come up with money metrics of that stock of knowledge. And so we can look at this R&D spending trajectory for the US over the last 50 years, and myself and other colleagues have done a lot of econometric work that shows that it actually takes about 50 years from the time you first spend $1 in food and ag R&D to when you exacerbate the impacts of that dollar in terms of its productivity consequences on the landscape. It doesn't mean you wait 50 years to have an impact, but you wait some years while you're doing the research before you have any impact. And then as those new technologies get adopted, they have an increasingly larger impact on output and productivity performance. And then they eventually become obsolete, or they depreciate in their effectiveness. And so that pattern that you see on the green line at the bottom is sort of the time path of the impact of $1 spent 50 years ago on impacting productivity or output in 2019. And so we can go through and do some maths and add up all of that historical investment and come up with a money metric of the stock of knowledge. And my estimates are in 2019, we've got about $3.75 billion worth of knowledge that's currently driving, public knowledge that's currently driving the food and ag sector in the US. And so what I did was I looked at the trajectories over the last 3 or 4 decades in our spending patterns and did a forward think about where our stock of knowledge would be in 2050. And so the first 3 rows in this chart indicate current investments in 2019 of $3.1 billion, holding that investment constant through to 2050. That's the first row. The second row is taking the observed rates of change in public investments in the US from 1990 to 2015, which was 0.81% growth per year, and projecting them forward to 2050, and you'd get just over $4 billion of spending in 2050. And the negative growth is what we've been seeing since 2005 to now. We've been disinvesting in the agricultural sector. And so if we project that forward, instead of investing $3.1 billion now, if we kept that trajectory going forward, we'd be only investing, in real terms, inflation-adjusted terms, just short of $1.3 billion. If we add all of that up into a stock of knowledge, the sorry state of affairs is that none of those, what we're doing is we're actually deprecating the stock of knowledge because we've baked in a decline in the stock of knowledge because of the disinvestment from agricultural R&D over the last 2 decades. So the bottom line there indicates the level of investment we'd be required to make. We need to go from currently around $3.1 billion up to just shy of $6 billion, just so that by 2050, we'd maintain the stock of knowledge driving agriculture in 2050 that we have today. That's not to grow the stock of knowledge, that's just to hold the stock of knowledge constant. At a very time that we have growing pressures in terms of international competitive pressures on the US agricultural sector, we have lots of issues that Eric's going to talk about growing expectations of the agricultural sector to service ever stressful more soil and water and other environmental aspects. We have changes in those environmental aspects that's making it harder to maintain productivity levels and so forth. So all of the indications are we should be doubling down at the very time we see that we're not. And just to hold that stock of knowledge constant, in inflation-adjusted terms, we'd have to increase investments from now to 2050 by over 2% per year. So if we factor inflation in, that's a 4, 5, 6% nominal increase in R&D spending to grow the stock of knowledge by 2050 to take account of all those new challenges. To get away from abstract dollars and cents and to sort of try and give you a feel about how the current and future look of productivity performance is, and to emphasise this fact that we need to think in a very long run terms. Those R&D lags that I just described, I put them in the context of what we call a Red Queen effect, in that when we introduce a new, say, wheat variety into farmers' fields, all the pests and diseases that sit around and attack that wheat variety don't just sit still, they co-evolve around the resistance genes and so forth that modern science builds into those new varieties. And we're all familiar with that case over COVID, that as we kept introducing new variants of a COVID vaccine, the COVID itself would mutate around those, and so we were in this Red Queen effect that we were having to invent around nature, inventing around our inventions. And so that happens to us, and it happens to livestock, and it happens to crops. And so we dubbed that the Red Queen effect from Alison Lookingglass. We have to run pretty hard in agriculture just to stand still. If we want to do better, if we want to increase yields, not just maintain yields, we have to run even harder. And so this is some work that I have underway with colleagues showing just the global pressures and risk exposures of wheat crops, for example, around the world, one of the staple food crops. And what we've done is looked at the 13 major biotic threats in wheat crops and looked at over 400,000 pixels on the planet and saw these pests like a particular climate regime, and so looking at the climate regimes across the planet, what is the risk exposure of those wheat crops around the world? And you can see in the US, it varies that some areas in the US are exposed chronically to 1 or 2 or 3 pests, but some areas are exposed up to 12 or 13 pests in terms of risk exposure in those crops. But in areas like China, South America, and in Africa, major exposure to risks with respect to wheat production. So how does science tackle that? Well, one of the main ways is to breed resistance genes into wheat varieties. And so this is an example where in the bottom, this is 100 years of varietal change in the US wheat crop over the last century. Each of those colours indicates a different variety, and you can see that there was waves and waves of new varieties that were folded into the US wheat production scene, and that the grey areas, or the coloured areas, are the top 5 varieties. You can see that shrinks over time. And so what that means is that we've been actually diversifying the varieties that support our wheat crops over time, such that we now have a much more densely varied pattern of wheat production in the US, and we're turning our varieties over faster and faster. So we have a lot more resilience through science built into those wheat crops, which help us protect against climate change and pests and diseases and the nature. So back in the day in 1919, there was less than 1 variety per million acres in the US, and now there's over 9 varieties per million acres. So we're tailoring the genetics in those crops to the local environmental circumstances. And so that's how we tackle through investments in R&D, but these are very sustained long-run impacts in R&D investments that give rise to those changes. Just to finish up, what we see in the reality of the data, though, is on the left-hand side here, is the share of USDA expenditures that have been going into R&D back to the 1880s. And you can see back in the day, the USDA was actually founded. Its first article of incorporation was focused specifically, the charge to the agency was to discover and disseminate new knowledge to farmers in the farming community. And so it was founded as an innovation agency. And so back in the day, well over half of the total USDA budget was dedicated to R&D. Over time, you can see that red line just declining over time, and it's been hovering down a low level ever since. And so over on the right, we see now in total USDA spending in the slice of the farm spending, just 1.8% of that total federal R&D spend goes into R&D. So the bad news is that we need to really grow the investments in R&D spending. The good news is we could re-slice that pie up a little bit and divert some of the funds that we've got in other areas that may not be as productive in terms of yield increases, yield maintenance, or dealing with environmental consequences on or consequences of agriculture, and get large payoffs from those R&D investments by just re-slicing the agricultural pie in the US. So that's it.
Thank you. Well, a lot to chew on there, and I suspect we'll have lots of Q&A, interesting discussions. Before we get to the insights from our discussants, Dr. Lichtenberg is going to talk about conservation policies and whether or not, and to the extent to which they may work to facilitate improvements in the environment, in carbon emissions reductions, as compared to other options that may be available. Dr. Lichtenberg, it's all yours.
Thank you. Okay, let's see. Do I have slides? Great. Thanks. Well, that was great, Phil. And I think a good sense of sort of the challenges in front of us and the distance that we have to go. I myself have been, I guess, concerned about the lack of government investment in agriculture. I think we've gotten a little complacent over time. We've done extremely well in the past, and I think it's led us to be a little complacent, thinking that we don't need to keep up the pace as much as we do, because the Red Queen effect is, in fact, very, very strong and omnipresent in enterprises like agriculture. Now, I want to talk about the conservation programs in the Farm Bill and how they might be used to deal with challenges of climate change. And unfortunately, that means that something of a deep dive into the structure of these programs, how they work, things like that. So a little more organizational detail, a little less excitement and more in the weeds stuff. Okay, so first, we know that farming is going to have to both adapt to climate change, right? We're going to need new crop varieties that are better suited for new climate conditions. We may have to shift locations where crops are grown because the old locations are no longer suitable. We're going to need to develop farming practices that are, again, better suited for new climate conditions. Okay? Also, agriculture can help mitigate climate change by changing land use to sequester carbon, using farming practices that reduce greenhouse gas emissions as well as sequestering carbon. And we have programs that, in fact, can be used for both mitigation and adaptation. Okay? And I'm going to concentrate on sort of the big programs where the money is, essentially. And for those not familiar with farm conservation programs, they are the ones here on the slide. The Conservation Reserve Program, it's a land diversion program. What it does is that it pays farmers to take cropland out of production, convert it to grassland or forest, some conservation use, and keep it in that conservation use over a 10 to 15-year period. Okay. There's also the Environmental Quality Incentive Programs, EQIP. And what that does is subsidize the installation and adoption of resource conserving or environmentally beneficial farming practices. And there's a 5 or 10-year contract involved. There is the Conservation Stewardship Program, which basically pays farmers to continue using a suite of environment-friendly or resource-conserving farming practices over a 5-year contract period. And then finally, there's the Regional Conservation Partnerships Program that kind of leverages EQIP and CSP funds to focus on environmental problems or resource conservation problems in specific areas. Okay, now, in terms of where the emissions from agriculture come from and the potential sources for carbon sequestration, we have this chart on the left from the Environmental Protection Agency. You can see that the sources of emissions are roughly equally divided between crops and, so the next two biggest bars, livestock, okay? Our famous cow farts, along with manure management. The right-hand side is from a fairly recent article that tried to estimate potential for land use changes, including farming, for sequestering carbon. And what you can see there is that forestry is by far the largest potential source of carbon sequestration. So we can take carbon out of the atmosphere, mitigate climate change that way. You can also see that there's a fair amount of potential from a number of different kinds of farming practices. There's cover crops, there's incorporating biochar, there's better manure management, things like that. Okay, so agriculture has some significant potential for mitigating climate change. Okay, let's start with mitigation per se, and let's start with the Conservation Reserve Program. Okay, as a land diversion program, it might well be very well suited for carbon sequestration, because what you can do is you can take land out of crop production and put it into things like trees, put it into things like grasses with deep roots that sequester carbon. Right now, that's not what the CRP does. Okay, the map on the left shows locations of CRP acreage today, or as of last year. And you can see the dark blue areas are the locations where there's lots of CRP land. Map on the right shows potential for carbon sequestration, with the bright green areas showing the highest potential and the orange and yellow areas showing the lowest. And what you notice right away is that the dark blue lines up with the orange and light yellow areas. In other words, where the CRP is today is the areas with low potential for carbon sequestration. Okay. Why? Okay, well, to understand how CRP land gets put into the program, have to take a little bit of a tour of the process that's used to allocate CRP funding. Okay. Now, every year there is a sign-up period, and farmers who are interested in enrolling in the CRP will designate a parcel of land, and they will bid. They'll put in a bid that said, I'd like to enroll this parcel, and I want you to pay me so many dollars per acre. So they bid the annual rental payment they want. Okay, so technicians from the Natural Resource Conservation Service of USDA, NRCS, go out to that parcel. They have a template. They evaluate the potential environmental benefits from that parcel. Okay, and there's a standard checklist that they use. And then back at headquarters, people put together an environmental benefits index, or EBI. They combine the environmental assessment and the rental bid into this EBI. It's a weighted average of those benefits and the cost. And then what they do is they start with the parcels that have the highest EBI, and they offer them a chance to sign up, and they keep on going until they've either run out of money or they've hit the acreage cap that Congress imposed, okay, whichever comes first. It happens that the EBI is constructed in a way that makes it want to enroll land in the plains and some in the high desert, okay? There's essentially heavy weights placed on things like wildlife habitat, which turn out to be things like pheasants and ducks. Okay, we're not talking about endangered frogs or anything like that. And things, factors associated with wind erosion, all things that you can find in abundance in the plains. Well, it is possible in principle to rejigger the EBI to give greater weight to carbon sequestration. Carbon sequestration is in there, it just has a very low weight. It's doable. The politics could be a little fraught, okay? Because you can see from this chart here, what doing that would mean would be taking CRP land out of the areas where it's most commonly found today, areas that have lots of agriculture, and where agribusinesses have lots of clout, and putting it into areas that don't have lots of CRP land today, don't have as much powerful agriculture, and don't have as much clout. Okay, let's look a little bit at policies aimed at working farmland. Okay, EQIP and CSP. Both of them provide subsidies for farmers to adopt what we might call climate smart policies, right? Policies that would both adapt to climate change and help mitigate climate change. Using EQIP for that purpose turns out to be rather difficult. And the reason is that, the reason again comes from the way that EQIP money is allocated. Okay, there have been programs like EQIP since the days of the New Deal. Okay, so EQIP's predecessors date back to the New Deal days. And the methods for funding programs like this also date back to the New Deal days. Basically, the money is divided up among states according to more or less how much agricultural activity there is. Each state then sends out its money to counties in the state, again, according to more or less how much agricultural activity there is. And then in each county, there is a county committee elected from and by farm businesses in that county. Okay, and that county committee is responsible for looking over farmers' requests for funding and deciding which projects should get funded. Okay, now, and there are also some restrictions on how that money can be used. So the 2018 Farm Bill specifies that half of EQIP funding goes to livestock related practices, another 10% goes to wildlife habitat. Okay. Reallocating money to places where the potential for climate change adaptation and mitigation is greatest is going to require changing the way in which money is distributed. And those distribution mechanisms are written into the Farm Bill. So the only way to do that is to essentially rewrite the way that funding is allocated in the Farm Bill. Things are a little easier with CSP. 2018 Farm Bill says, okay, what you're going to do is NRCS is going to go out and they are going to take in bids and they'll rank them according to identified needs for resource conservation and environmental benefits, areas where there's the greatest need, and again, the potential for these projects to address those needs. And those changes, that mechanism is more administrative and is much more easily changed for that reason. Okay, so NRCS could come and say, well, we have a much greater need for climate change adaptation and mitigation than we thought we used to have, and it's time to change the way we rank things. So that's more easily doable. Okay, we're economists here. I'm an economist. And so I've got to talk about efficiency because it wouldn't be an economics talk without talking about efficiency. Okay, efficiency here, what we're concerned about is what's known as additionality, right? We know that some of the money we spend is money for projects that farmers would have done even if we didn't give them money. Okay, that's just going to happen. It's always true when programs are voluntary. And we've had a number of studies in recent years showing that additionality, okay, which is basically the share of the projects that farmers wouldn't have done if they didn't get paid. So the share of projects that government money is directly responsible for. Those studies show that additionality is far from perfect. It's quite imperfect, okay? And in fact, some theoretical work done by a couple of my former colleagues, John Horowitz and Richard Just, showed conceptually that imperfect additionality is probably a necessary feature of voluntary programs like these. On the other hand, it is always important not to let the perfect be the enemy of the good. Okay, these are programs we have in existence. They can be used for climate change adaptation and mitigation. They can be used to address the biggest problem facing humanity right now. And what's more, these programs have some administrative advantages. They're piggybacked on delivery mechanisms that are also used for a variety of other programs, and so the costs are probably lower than a standalone set of programs would be. Okay, I'm going to skip over carbon trading and stuff like that. Suffice it to say that cap and trade and these subsidies don't go along too well. Carbon taxes and these subsidies go along a lot better. I want to say a couple words about the Inflation Reduction Act and the Biden administration's Climate Smart Agriculture Initiative. The Inflation Reduction Act authorized a very large chunk of money, an additional almost $20 billion over 5 years, for programs aimed at conservation on working farmland. Okay, so EQIP, CSP, RCPP, and the Agricultural Conservation Easement Program. Okay, and you can see the dark tops of the bars on the very right-hand side are that extra funding, extra spending in just FY 2023 and projected for 24. And in fact, USDA has already approved over $3 billion for almost 12 dozen climate smart commodity programs. Now, these partnerships are highly diversified in terms of the geographic locations they address, the kinds of organizations involved. You have your traditional commodity groups, farm groups, you have agricultural processors, you have sustainable agriculture groups, you have Native American tribes, really runs the gamut, okay? And of course, the kinds of commodities involved are also highly diversified as well. Well, you know, when you see money being, I don't know, tossed out of helicopters like this, you ask, well, is this just pork as usual? And my off-the-top read is, no, it's not. And the reason has to do with some important features of agricultural R&D, okay, which is all agricultural R&D has to be localized. Farming is something that takes place under natural conditions. It depends heavily on climate. It depends on natural resource endowments, and all of these things vary a lot from one place to another. So we need new crop varieties that are bred to be suitable for specific climates and specific resource endowments. We need new farming methods that are modified to accommodate specific climates and specific resource endowments. And that means that climate-oriented R&D really has to be diversified by geography, by commodity. Okay, so that fact of agriculture in itself says we need broad diversification of our agricultural R&D. Something else. Some of these projects are going to fail. This is a certainty. That's okay. It's actually probably a good thing in a way. You know, we're at a fairly early stage in developing mitigation and adaptation strategies. We need to be trying a lot of things. Sometimes we learn from our failures at least as much as we learn from our successes, often more. And so we need to be, since we're at an early stage, we need to be learning as much as we can. And that means that we should try some things that probably are not going to work out. I have heard somewhere that, if you're in research and you don't have some failures, you're not taking enough risks. And as a country, we are large enough and rich enough to afford a fair amount of risk. And so to me, the diversification, the throw everything at the wall approach taken by the Biden administration is actually a sound strategy. Okay, just to sum up, we have some Farm Bill conservation programs. They're here. They can and should be used for climate change mitigation and adaptation. We'll need to have some changes in program structure and implementation to reorient them towards climate change. We know that there are going to be some limits to the efficiency with which they can work because they are voluntary programs. And finally, as I just said, I think diversification of climate-smart agriculture R&D projects is definitely a sound strategy. So, thank you.
Eric, thank you. That's a wonderful walk through a complicated world and raises some really interesting questions about how funds should be used. Dr. Capitan, thank you. We owe a great debt of thanks to Dr. Capitan because one of her colleagues was originally going to share in this panel and has unfortunately become ill. And she stepped in almost literally at the last minute. We look forward to hearing your insights about what the Foundation for Food and Agricultural Research is doing and where your work is influenced by and sits in the current environment that has just been laid out by Dr. Pardee and Dr. Lichtenberg.
Good afternoon. Can you hear me all right?
Yes.
Great. Thank you. That was just two wonderful presentations and really appreciate hearing that. FAR can step, the Foundation for Food and Agriculture Research can step in the numerous of the ways that, sorry, I'm hearing an echo. Is that just on my side? That's
just
not
on your
through
side.
To you?
You sound,
okay, I will.
You sound almost perfect.
Great. I will ignore it then. So the Foundation for Food and Agriculture Research was established to fund public-private partnerships to advance food and agriculture research, responding to the decline in agriculture investment in research that Dr. Pardee mentioned. And since 2014, when we were established and funded again in the 2018 Farm Bill, we have invested in food and agriculture research with partners from the private sector, from producer associations, foundations, nonprofits, academia, across the spectrum of agriculture research needs in this country. But specifically responding to some of the needs that were highlighted by both the previous speakers, FAR has actually invested quite a bit in research that is designed to help agriculture adapt to climate change and to mitigate climate change. And examples we heard about drought-tolerant crops. FAR has funded in collaboration with Washington State University research to make wheat more drought-tolerant, for example. Other cereals, making them heat and drought-tolerant, but also really investing in understanding trade-offs between what farmers can do to mitigate or adapt to climate change and how they might adapt those if they're more profitable or productive on their farm. So our research is really designed to think about how to help farmers adapt to climate change or to mitigate climate change by specifically targeting and developing technologies that will make their farms more profitable as well as more resilient in the face of climate change. I think we all know that a farmer is not going to adopt something that's going to cut into their bottom line. They're already cutting it close as it is. So really solutions and technologies, and Dr. Pardee again said it can take some time. So those research investments are needed now, and research investments that will really bring that resilience to a farmer's field or to their operations, for example, in caring for animals. I can give some examples, but I want to see if I should do that now or later.
Oh, this is your opportunity. Go ahead, please.
Okay. Just a few more specific examples. We fund the FAR Fellows program, students who are working across the range of agriculture. And it was interesting, just in light of the presentations that were made, we actually have FAR Fellows that are working on understanding, bringing machine learning as one example of machine learning to how we look at plant leaves and count stomata on the leaves, which is just a thing that you have to do in order to better really improve the efficiency of a plant. We have another FAR fellow who is looking at engineering plants to reduce the number of stomata and make them more water efficient. So really bringing the best and the brightest minds to working on this problem and taking some of those risks and bringing players together to think about how you might make a plant more water efficient, more drought tolerant, and using the most advanced technology we have, biotechnology approaches or machine learning, artificial intelligence, to doing that in a way that the farmer themselves won't have to really hugely change their practices, for example, to adopt a new crop. Another example is a project we have with the Ohio State University, Dr. Ratan Lal, looking at carbon in soils and really understanding the dynamics of how we could use soils to sequester carbon and really ensuring that that we have good measurements and understanding of how to do this, so that if we're asking a farmer, for example, to voluntarily take up a new practice, we actually know that it will have the impact that it needs to have in order to mitigate climate change. A third example, the last speaker mentioned cows and their contributions to greenhouse gas emissions through methane, through the gases that they release. And we've joined together with a number of industry partners to form the Greener Cattle Initiative. So this is a consortium where industry partners are partnering with us. I should have mentioned that FAR's funding model requires that every federal dollar that we spend, we match it with a non-federal dollar. And in fact, we've gone above and beyond that. We've matched every federal dollar we've invested into research with $1.40 of non-federal funding. So really magnifying that taxpayer investment. And through the Greener Cattle Initiative, which is a consortium bringing together a number of industry partners who are co-funding this research with us, we're exploring a number of different ways in which we can really reduce the contributions of cattle to methane emissions. And we're having technologies that producers can use in their operations to reduce those methane emissions.
Well, that's great. Your funding level is at roughly what level from the federal government right now?
So we were funded in the 2014 Farm Bill at $200 million, and then again in the 2018 Farm Bill, $185 million.
So that's about $45 million a year? If I set it up annually, is that about right?
Yes, although we've actually, because FAR was a brand new organization in 2014, I would say our spend levels haven't been just evenly over the years and have been increasing. And in just the last year, we funded almost 130 million in awards, and it was close to 50 million from the Farm Bill funding and almost 80 million from matching funds.
Okay, that's really helpful. Thank you. We're going to turn now to Kenneth Parker, who has to grapple with these issues literally on the ground and in the cowshed, I guess. Ken, what are your thoughts about the role of agricultural R&D, the challenges associated with conservation and managing in the future greenhouse gas emissions from both crops and from livestock?
Well, Doc, that's a great question, and I guess that's why we're all here.
Well, yeah.
But, I really think, at the end of the day, starvation is not an option, and destroying our environment is not an option. There's a way to do both. We will sustainably feed humanity, and we will take care of our environment. But I love this group out here. It's a group of young people. I don't know where y'all. Do y'all drive into Washington every day? It's great. They must be interns, but this is a great group. I'm going to speak to y'all because I don't know what's out there on the internet. But when I look out here, I see the answer to all the questions we're asking is right here. They will be able to answer these questions. So I'm going to throw out, there's 5 big tables here, and there's a lot of lot of y'all here. I'm going to throw out some things that I know to be true and accurate, and then I'm going to throw out some points of examples maybe for further discussion, because I think that y'all should be engaging on this. And you are correct. I do not grow strawberries. I work for the Strawberry Growers Association. Clear
You
that
have
up.
in your life, I know that.
Well, yes, I have worked on the strawberry farms, and I served as a certified crop advisor for over 20 years, primarily in the strawberry industry. So I have lots of boot tracks on the ground in strawberries. But thank you, Vincent. So I know this to be true. American farmers and ranchers have always been productive and extremely resilient, due in large part to past investment in research and development. Dr. Pardee, the trends that you highlight, they are of great concern to me, and it should be of great concern to all of us. The spending, the funding, what the trend lines look like. Increased production using less inputs is vital to sustaining our food supply and our environment. As climates change, research changes. Best management practices should be living documents, underscoring the need for reoccurring research and development funding at a much larger percentage of the USDA budget than currently exists. Now, some priority areas of funding and further discussion would be, and these would be examples of direct positive impacts to farms and ranches and the benefit to our society and the environment. And I would start with applied plant breeding. And maybe we've heard this before, but it's true. It's very true. We need impact-driven research, not just hypotheses. Applied plant breeding and selection of new cultivars that have increased tolerances to adverse climatic conditions and pest and disease pressure. Example number 2, pests and diseases. The increase in invasive pests and new or emerging diseases, coupled with the lack of effective crop protection materials, has greatly increased the need for applied research, and somehow we have to figure out how to incentivize new chemistry development, particularly in specialty crops. Mechanization and applied artificial intelligence. Effective mechanization made possible by artificial intelligence is critical to the sustainability of labor-intensive crops. But it doesn't stop with trying to solve the labor issue. Applied artificial intelligence can and already has reduced costs of inputs and natural resources. And I know that we are just at the tip of the iceberg when it comes to how applied artificial intelligence can make a positive impact on not only agriculture, production agriculture, but how it can help production agriculture be part of the solution to creating a sustainable environment. Ecosystem services. As our population grows in number and the need to increase our food supply, we have to protect our environment and understand the value that farmers and ranchers passively provide by choosing to maintain vast amounts of land in agriculture. Research has to be implemented to identify and quantify the benefits to society. If agriculture is expected to be a key player in ecosystem sustainability, agricultural endeavors must be profitable. We should recognize and compensate farmers and ranchers for the ecosystem services they provide, as well as being compensated for the food and fiber they produce. I'll leave you with a couple of final thoughts, just throwing out there on the table. This is true. I believe this with all my heart. Food security is national security. And secondly, the coexistence of a healthy humanity and a healthy environment rest on the shoulders of a robust, reoccurring funding of applied agricultural research and development. Thank you.
Well, thank you, Kenneth. Thank you all to all of our presenters today. So I have two questions that I'd like the panel to grapple with, and not all of you may want to grapple with this question. How many dollars are we talking about in today's dollars in order to enable American agriculture over the longer term to A, increase productivity, and B, reduce its footprint on the land, which my understanding is that's the key way in order to address carbon emissions and other forms of agricultural related greenhouse gas emissions. How much money are we talking about? What should the budget be? Or by how much should it be increased? And from where should the funds come? I'm looking at Dr. Pardee because I know he's thought about this. But Dr. Lichtenberg has talked about this too. Kenneth is a traditional member of the American Farm Bureau, and he should care about budget deficits and funding and where's the money coming from. But before I ask any of them, I'm going to ask our colleague from FAR what she thinks about the funding level, if that's not a too difficult question.
It's not a difficult question, but it's not one I'm going to weigh in on specifically, given our role in relation to the Farm Bill. However, I think what's critical is that there is ample publicly funded research in the mix. We love working with our partners across the spectrum, but in order for us to really do effective public-private partnerships, we need the public piece and the private piece coming together, and that's really where FAR operates, is in that wonderful space of bringing those public research funds in with the non-federal funds and really advancing partnerships that have the players at the table that can take that technology forward. So I know I didn't exactly answer your question, but that's the answer I can provide.
No, but that's a fair response. Dr. Pardee.
So I'm happy to weigh in. Sahara's working for an agency funded by the public purse, and although I'm an academic, so I can say what I like. Asked that question a lot, and I think it goes beyond perhaps, Vince, just the total amount, but also the form and the nature of the funding.
Yes.
And so I think, as Sahara was pointing out, as I showed in my first slide, the nature of who's doing the research in food and ag sector has changed dramatically. So I think of the food and ag sector as just like the rest of the life sciences now. It's like the health sciences. And if you look over in the health sciences, we've had incredibly significant increases in the private presence in that sector, but we've also had very large and robust and growing public investments in NIH and other agencies that are driving that research. So I often get asked, we can take the foot off the pedal with respect to public research because the private sector stepped into the breach, and I've looked at that hard, and I think on the margin there is some substitution going on, and the private sector has picked up some parts that the public sector was previously doing. But there's a huge pre-commercialisation and basic research space, which is clearly the domain of a collective action in the public sector, where there's much more limited ability for the private sector to capture the gains from those investments, and therefore that research will not be done. And the sorts of things Erica talking about, when not all of the gains from research are captured through private value chains, there is actual social value as well as private value created by the food and ag sector, and benefits are spill beyond the food and ag sector in terms of environmental benefits, which we all gain from, that require public investment. So, as I'd said, looking forward, just to stand still, the current stock of knowledge requires a doubling of current investments.
So is that about $3 billion a year?
Yeah, so we need to go from around 3.1 up to $6 billion. And all the economic evidence says that those past investments have yielded really high rates of return. If I had a bank account that was getting a 10 to 15% real rate of return over a 50-year period, I'd put my money in it in a heartbeat. That's what all the evidence. There are hundreds of studies on the returns. There's way more studies on the returns to food and ag R&D than there is on the returns to health R&D, because I've had students look at that. And all of the evidence, and Eric's right, there are winners and there are losers, right? So it's a portfolio of research. So not every research by its nature is risky, and some it pays off and some it doesn't. But the portfolio overall yields social returns in the order that I just talked about. And I also get asked the question, well, we made the easy gains in research 50 years ago, and so research is much more costly now, and it's harder to do science and more expensive, and the gains now and looking forward perhaps aren't as large as they were in the past. Looked really hard at that evidence too, and there's done a whole bunch of econometric work, and there's nothing in the evidence to suggest that in 50 years of returns to research evidence, that the returns to research investments made today are any higher or lower than they were 50 years ago.
They're very high.
So they're very high, and they've maintained that very high rate of return because the challenges but opportunities facing the ag sector are just as high, if not more so now than they were 50 years ago.
So just to be controversial, because that's something I never am usually. Eric, why not take the $3 billion a year that's in the Inflation Reduction Act and put it all into agricultural R&D rather than mess around with some of this cover crop stuff?
Good question. Well, because it's not just developing new crop varieties and new methods, but actually getting them out into the field and getting people to take them up. And in fact, we do know a fair amount about how well many of these kinds of farming practices can work. Okay, I first started working on cover crops in 1990.
When you and I were actually had colored hair that wasn't
When we looked like
yeah.
this, you know, not like this.
Well, not like many of the young people in the audience. They look far better than we ever did. But yes.
True enough, true enough. And even back then, it was very clear that cover crops do a lot. You know, we were able to quantify sort of how much. There's still adjustments to be made. There's still more work. I mean, look, here in the Chesapeake Bay region, we've done lots and lots and lots on things like this because everybody cares about the Chesapeake Bay.
Sure.
And there's been a lot of money putting into trying to clean up the bay. I don't think the same level of effort has been put in elsewhere in the country. We happen to be in a favorable location for things like cover crops because we have a long growing season. Like out in Montana, you guys don't.
Well,
Right, so-
in the West, cover crops have not been adopted. What has been adopted is chemical fallow, which achieves pretty much the same purpose.
So, as I said, you know, all of agricultural, the development part of R&D is also very localized. Everything has to be adapted to local circumstances, and you need to figure out ways to do those kinds of trials. Okay. And
Kenneth, you've described yourself to me as a traditional or pretty traditional conservative person.
Fiscally conservative, yes.
Yeah. Where should the bucks come from?
When you look at the USDA budget, and I'm no budget guru, but it looks like there's been things added to that budget over time that has continually brought down the percentage of investment to R&D over time. The USDA budget is huge. I think there's probably ways to create efficiencies within the budget itself that monies could be shifted back to R&D that are currently in the USDA budget. I think the money is already there without increasing taxes. I think the money is probably there. We just got to figure out where can we be more efficient in the dollars that are spent within that budget. And I can promise you this, if it's on average 15 to, I've seen as high as 20% return in some reports, we as a nation cannot afford not to invest in research and development for agriculture.
Well, I admit I have strong biases here too, and I completely agree with all three of you that we need to invest in agriculture. And I think the issue of where there are genuine services that are non-commodity specific services associated with agriculture, paying for those amenities out of the general public purse can sometimes be justified. I'm a little more cautious about that than perhaps others might be. Phil, where should the money come from? If not out of Eric's conservation budgets, where should it come from?
There's a sizable slice of that pie that's a transference program in terms of commodity support programs, of which you've written on way more than I have and understand the intricacies of that. So that literally is transferring taxpayer dollars from to particular farm participants, which is not what R&D is about. R&D is actually investment in creating value much more broadly than that. And so it seems to me, picking up on Kenneth's point, that there are room to move from sort of income transfer to income creation sorts of opportunities within the Farm Bill. And if you look at it hard, that slice is pretty small, 1.8% going into R&D. In the recent history, back in the 1970s and so forth, it was around 3 to 3.5% of the USDA bill going into R&D. And that was exactly at the period of time where we actually had some growth in the total R&D spend. And so it seems to me pretty marginal changes in the size of that R&D slice will actually generate the at least doubling, if not more, required to actually get us back to a growth in the stock of knowledge, which is driving all of these productivity, conservation and environmental consequences. And so I think it's as much also the form of the funding as well as the amount. I think Kenneth talked about 2 R's, a robust and recurring investment. And as I tried to make the case, it's not just the case of a one-off Farm Bill investment. We actually have to change the strategic trajectory of those investments relative than just a short fix of a one-time injection of funding in there. And I should mention too that as I look at the numbers, and we've looked below the totals going into the public sector system and looked at the sorts of research that's been invested in, and we've had a massive withdrawal of investments into productivity enhancing, productivity maintaining research. So not only is the total pie been dropping for 2 decades pretty precipitously, but we're now spending about half on productivity enhancing, productivity maintaining research, which speaks directly to the sorts of things Eric was talking about the complexities of maintaining productivity in the context of these changing environmental circumstances for agriculture, a sector that's more than any heavily reliant on natural inputs such as heat and light and water and soil. And if we don't do our best to steward those, we're also undercutting the long-run productivity potential of the sector itself. And so what's happened, if you look below the totals, is that there's a lot more research going on into nutrition-related research and things of that nature. I'm not arguing against those because the evidence says we need that research as well. What I'm arguing for is that the increase in research and expanded scope of the public sector ag R&D research program has come at the expense of, not in addition to, enhancing and maintaining productivity. And that's also part of the problem we've got now.
Well, let me turn to the audience. Are there questions from the audience? Well, I have a very specific question that came in online, which is, what are the impacts and benefits for everyday Americans of the Conservation Stewardship Program? And I know you talked a little bit about this too, how can the agricultural policy be reformed to improve the program? But this is definitely an Eric question.
Okay.
And it's going back to some of the discussion that you gave us.
Yeah. Well, since I have not studied the Conservation Stewardship Program in detail, I'm going to be fairly conservative about what I'm going to say about it. And it certainly has been debated as to whether it's a justifiable program. We're paying farmers to keep on doing what they are already doing, and why do we have to pay them? in order to keep them doing what they're already doing, and many of whom may well have found to be profitable. So that's one side of the argument. The other side is Kenneth. We have some farmers who we may be paying for ecosystem services provision, and there's some equity argument on that side. I wouldn't want to say any more without actually looking at what people have been doing under CSP, but I think both of those considerations need to be taken into account. It's not just, oh, well, they're already doing it, we're just going to pay them to keep on doing it, because that's a way of funneling money to some farmers.
We have another question from the virtual audience, which is for you too. And so I'm going to ask you this question, and then I'm going to bring in some other questions that the other panelists can talk about. So this is not my words this time. Cover crops have been well known and beneficial for decades, but have limited adoption. So why is such adoption so limited? Do they really need public subsidy dollars? And if so, why?
Cover crops have very public benefits and private benefits that are less so. Okay, certainly costs money to put in cover crops, costs money to kill them in the spring. Incorporating them into the soil does improve soil structure, so there are some private benefits, but mostly what they're going to do is soak up excess nutrients left over from the growing season and maybe sequester some carbon, and those are public benefits. They're not appropriated by farmers. And
what about soil erosion? Do they affect soil erosion?
They do help reduce soil erosion. And there are places where there are fields that are very much prone to erosion, and there are fields that are just not as prone to erosion.
Sarah Moon, have you funded projects looking at this sort of issue? Sahara
Looking at cover crops?
Yeah.
I'm new enough at FAR that I don't want to go into the specifics. I haven't memorized our entire portfolio, but this is definitely within the area of things we do fund. And really this question around what are, trying to understand what would be the benefits to farmers versus the public benefit would be so important, because I think that was very astute. If the farmer is going to benefit, for example, if it's a cover crop that will, fix nitrogen or increase nutrients in their field, then they will see that direct benefit. But if it's a cover crop situation that really brings that public good, then I think that's the answer to the question around, who needs to fund that. I think one of the things that we try to do is really understand what are the benefits that we can bring to farmers, and how can we introduce an innovation that perhaps generates that public good of sequestering carbon, for example, and also generates a private good in the sense that it could enhance productivity for farmers. So that's very much in line with the kind of research that we fund.
One issue that is embedded in all environmental regulation, particularly regulations that specify particular technologies, is that the world changes and the technologies that are best change. Now, this is an issue, Kenneth, that you raised, right? You talked about best practice technologies. So one of the big concerns that I have had in my life at looking at environmental issues, I spent several years looking at Clean Air Act issues, was the tendency for policy to mandate process and locking in that process when it would have been far better to have had a process that allowed for flexibility and innovation in processes that would better increase carbon sequestration, say in soils, or better increase yields so that land does not come into production. What are your thoughts on this, Kenneth?
I totally agree, Doc. And when I mentioned, best management practices should be a living document, I don't think you stop at best management practice, and I was trying to get a lot of points in a while ago, but I think you look at any research document that drives policy, it can't sit still. It has to be a living document. For example, simple example, strawberry growers fund research to know how much fertilizer is best for a new variety. We do this every year. We self-funded, because we have new varieties coming out now about every 4 years. We can go from start to finish where it was 10 years, but because of new technologies, being able to, when we make the initial cross, being able to take a sample of that first bud leaf, because we know the genetic markers that were actually desirable, that we're looking for, we can take the first bud leaf that comes out of that cross and know whether or not it has the potential to be what we think it can be. Yeah. Our breeding program at the University of Florida is incredible. And I know there are great breeding programs all across the world, but we have to be able to continue to reinvest, continue to fund on a reoccurring basis, because as technology changes, as the climate changes, as varieties change, science has to keep up. And when I mentioned the use of fertilizers and varieties, every variety is not the same. So we have to continually fund every time a new variety comes out. What's the best fertilizer recommendation in terms of nitrogen, phosphorus, potassium for this new variety? So we cannot keep a static figure. One size does not fit all. Research has to be ongoing and reoccurring.
Both at the applied and at the basic level as well.
Absolutely.
Yes, a question at the back there.
Thank you. My name is Ingrid DeGroot. I work here. I have lots of questions, and I've been trying to decide which one to ask. But for Mr. Pardee, could you elaborate on what the dangers, the minuses are of the shifting ratio of public R&D to private? Yeah, did I say public R&D to private R&D? So, what exactly is not getting done? What research isn't getting done because it's shifted so much to private rather than public R&D?
Yeah, I think it's probably more a matter of not that what research is getting done because of that shift. A lot of research is not getting done in the public sector because of lack of funding. And so, as I tried to make the point earlier, often the public and private sector tend on the margin to be more complementary, that is additive rather than substitution. So it's not a matter of we're doing less research in the public sector because the private sector is picking it up. We're doing less research in the public sector because we've got less funding going into the public sector. And so, but it does raise issues about how the private and public sectors interact. And so the centre I'm now directing was actually devised and driven by this very observation that the changing realities of food and ag sector is that the private sector presence is much larger. And so that comes with it issues related to access and use of data driven by the private sector, and does that get locked or siloed within a particular private company? Or is there ways that we can be creative, because data, all research is done for one immediate purpose, and that is to generate data. That data hopefully leads to better decisions and better technologies and so forth. But the very first instance of that research outcome is data generation. And if a lot of that data is left siloed in private interest, just as it can be siloed in individual labs within a university, for example, then there's a lot of innovative opportunities left on the table untapped. And so we've been trying to think creatively about thinking about, on the one hand, there's open data where we make data freely available, but that then undercuts the private incentive to invest in data creation where they want to actually capture some value in that data. So Sahara's driving an institution which is actually trying to do something different, that is bring the public and private sector together in this pre-commercialisation area where there's collective interests that exceed often the capacities of even larger companies to do the research, but collectively they all share in some value from that research. And in fact, our centre is actually supporting collective action by 7 research consortia of FAR that come together in a public-private space where they decide on the rules of engagement as to what data gets used and how it gets used, with an ultimate objective on FAR's case of letting that data go out in the public domain, but incentivising the private sector to get a sort of first dibs at the data, if you will, that they're collectively creating to further their own interests. And so I think there's a lot of creativity we can do to try and incentivise public-private partnerships so we don't have all the private data locked up in the private sector and all the public data necessarily in the open sector, but I call it purposely pooled data. It's a tongue twister, but it works in terms of how can we incentivise people to pool their data to tackle these real problems that where the private sector are really good at the D, at the development end of the spectrum, and the public sector are really good at the R, or the basic research end of the spectrum. How do we actually bridge that divide? And I think the proof is in the pudding. There's lots of opportunities there to actually create those partnerships in ways that weren't required in the past because of the dominance of the public sector in the research, but are required now because of the dominance of the private sector. So I see it as a major win opportunity rather than a negative. I mean, I'd much rather have another $7 or $8 billion of private R&D investment going into the food and ag sector than not having that investment, for sure.
The way I would have put it, Phil, is a little bit different than you put it, but underlies the more complex vision you just presented. We talk about crowding out or crowding in. The evidence is pretty compelling that if you expand public R&D investments in agriculture over the aggregate of all effort, that crowds in more private research. So they're more synergistic than competitive. Is that a fair statement?
That's a good statement.
In the last couple of minutes, well, 4 minutes, I want to turn to a very big picture issue. We do hear folks say, funding agricultural R&D only benefits farmers, or funding in agricultural R&D should be done only in the private sector. There's a national security and an international security issue. Hungry people are people who are going to be highly problematic in terms of their political behavior. If we have hunger in Africa, we have created, in some sense, in a global sense, we have created the potential for increased terrorism, for increased international conflict, to put it that way. In that context, how critical is it actually that the United States significantly increase agricultural R&D investments, not just because of their local effects, but for their spillover effects, their benefits globally for global agricultural production and global food security? Or is that just an argument that someone who wants more money from, let's say, Michigan State University will make?
If you're directing it to me,
well, any of you.
My personal and professional experience, I spent 20 years working in the international agricultural research system, and know full well the major impact that US innovation systems have had throughout the developing world, particularly in sub-Saharan Africa, where, as I pointed out earlier, their share of the global R&D pie is really small and actually shrinking. And when you look at hunger in the face, you realise that actually lowering the price of food has a huge impact on hungry people who spend 80+% of their total disposable income on food consumption. And so any marginal decrease in the price of food has a disproportionately large impact and a highly distributionally equitably positive impact on poor people, not just in Africa, but also here in the US, I should add. There's a lot of hungry people in the US who are very sensitive to the price of food. And so the United States Agency for International Development has been a bellwether of funneling the impact of innovation systems in the US into developing countries. Their budgets, like the domestic budgets for ag R&D, have been really challenged in the last several decades, and particularly around their investments in R&D, where I know much more about their budgets, and their investments in the international agricultural research system, they're still a major player, but that international agricultural research system has also seen its budget fall nearly 40% since 2014. The problems that they're trying to face haven't been cut by 40%, and so I totally agree, Vince, that the US has played a very large leadership role in sort of global innovation in food and ag, which is challenged as well, given the current budget realities.
So Sahara Moon, in your career, you've worked in developing countries as well. What are your thoughts? You've got 20 seconds because that's all we have left.
I agree with everything Phil said, and I would add that, emissions know no boundaries. If you can really reduce emissions and make agriculture more efficient around the world, we're going to get that much closer to mitigating climate change. We can't expect American farmers, of course, to do that. So I think that as we make investments that address global challenges and come up with solutions that can be applied globally, we get ourselves that much closer.
Well, that's a great note to end on. The US has a major role to play nationally and internationally in agricultural R&D, and hopefully Congress will pick up the slack and do great things. Thank you, everybody. And